Okay, so welcome back. This is part 2 in our series where we're going to show you how to develop this really cool C# Visual Studio Windows Forms application you see here. And what this application does is it goes out and makes a request to a web server, and every second or two it will make the request and then grab data that gives us the location and heading of aircraft, and we specify to the server what is the latitude and longitude that we want to detect aircraft in, and also what is the range or the radius in miles around which we want to detect the aircraft. And here you can see what we're doing is every second or two we're making that request and then grabbing the resulting data and parsing it. And we are, in this case, we have 9 aircraft that are in the airspace. Now we have 10 aircraft in this airspace. And this particular one is out in California in the Palm Springs area. And we're taking that string of data that the server is sending us every second or two, and we're parsing it, and we are assigning each aircraft that it tells us about to a picture box, and we are taking the data for that aircraft and we are updating it every second so you can see where each of these aircraft is heading. And every second we're changing the location and the heading so you can monitor the aircraft. And we're also taking 4 random aircraft out of this stream of data and giving us more information, such as the company, the description of the aircraft, the distance from the center of this map, the altitude, the ground speed, the call sign, and the track or the heading. So here you can see we've got 9 aircraft. We're updating it every second or two, and we're changing the location and the heading of those aircraft. And as they go outside this range of 30 miles that we've requested, you can see that the aircraft will disappear, and as others come in, they will appear. So that's what our application is going to do. It's going to make a request every second or two, grab the data, parse it, and then apply it to images in this application so we can update the position and rotation of the aircraft every second or two. So what we're going to talk about in this video is we are going to look at perhaps the easiest part of this, and that is how we can go out on the web and make a request to a server for this data. And there are a number of websites you can use for that. However, we're going to use a free and open source website called airplanes.live. And basically all we have to do is send a string command that has the latitude, longitude, and total range that we want to detect the aircraft in anywhere in the world pretty much, and it will send us back the information we requested. And we can make the request every second or two, and we can update this map with the latest aircraft information. So let's go to the airplanes.live website and see how we can do this. So here is the website, airplanes.live. And this is a really nice website where it has not only the ability that you can grab this tracking information, but you can also click on this tracking and it will give you a map of any location in the world, and it will show you in real time the aircraft that are detected in that area. And here is the area that we have our map in right now, which is centered on Palm Springs in the United States in California. And it's got all of this information about the aircraft that are detected in this image. And you can see it's updating them just like we're doing. But also what you can do is you can go in this data and go to the API, and that is Application Programmer Interface. And what that does is it tells you what you can do to request the data every second or two and what the data it will send you in return. It's got some example usage if you go to the API guide. And here's some things that you can request. What we're going to do is we're just going to request a latitude, longitude, and radius. Returns all aircraft within a certain radius of a given point. And also it will give you, you click on example JSON output, and this is the string of data. This is just an example for one aircraft. the long string of data that you can receive for each aircraft. And we talked before about how we're going to have to take all that data and parse it. But the first step we're going to do is we're going to figure out how we can access this string of data, how we can grab it every second. Now, another thing to keep in mind, if you want to contribute to this community, you can also build your own very inexpensive sensor with an antenna and a piece of radio equipment. You can use like a Raspberry Pi, and you can sense in your area, you can sense whatever aircraft are there and send the data over the internet to add to this. So you can contribute to this, and I encourage you to consider that. But what we're going to do is we're going to take a look at how we can write some very simple C# Visual Studio Windows Forms code to request the data and wait asynchronously to get the string of data, and then we're going to parse it. So here is our C# Visual Studio Windows Forms application that we are using to get this complete tracking application. But what we're going to look at in this video is just the part where we send a request to the web server and gather the data. So what I'm going to do is I'm going to go into the methods that we have, and there is a method here that actually goes out, gets the data, and returns this is asynchronous, so it returns a task of flights. And flights is a class that we're going to have to develop where we take the string of data, the JSON data, and parse it into a class called flights. And once we have that class, we can think about processing the data and then displaying it. So here is the important, very short method, asynchronous method, and basically it's going to take a latitude as a double, a longitude as a double, and a radius. And it's going to use those to say, okay, grab the detected flights in that latitude, longitude, and radius and return it to us. Now, in order to do this, we're going to have an HTTP client. And we're going to have to add system.net.http. And also to parse it, we're going to use newtonsoft.json. And we'll talk about how to add those, but it's pretty straightforward. But here is our method that's going to go out and grab the data. So it's public, asynchronous, static, and returns a task of flights, which is a class that has all the flight data. We're going to call it getPlanesAsync, and we're going to say var HTTP is a new HTTP client. And here we're going to develop the string that we have to send to request the data. And really it's very simple. We're going to call it request. It's a string https://api.airplanes.live/v2/point, as we saw before, / and then we're just going to have to add the latitude, longitude, and radius as strings. And we're going to come out with a complete request string that we can send. So we're going to take in the latitude as a double, convert that to string, add a /, the longitude to string with a /, and then the radius to string. And that's it. So you just need to send this link with the latitude, longitude, and radius, and then you await, this is asynchronous, you await http.getAsync this request. Here's the request, you await the request, and the response is an HTTP response message. So we're going to wait for that. Once we got that HTTP response message, we can say await response.content read as string async. So it's going to take that response as a asynchronous string, and it's going to give us a string result. And that's going to be, as we talked about before, something that looks like this, but it's probably a lot longer, since this is only one aircraft and it's going to have multiple aircraft. You can have, 10, 20, 30, 40 aircraft, so it's going to be a very long JSON string. But basically, that's going to be the string. And then what we can do is we can use this JSON convert.deserialize object. So it's going to take this string and we're going to feed it this result and convert it to a flights class, and it will give us an object that contains all of the flights in our flight class, and then it will return that. So basically it's taking a whole big string, mapping it to our flight class that we'll talk about next, and then returning that each second as we make the request. So to go to a different location, we just have to change the latitude, longitude, we can change the radius. But this basically is going to give us a flight class with a bunch of flights, or however many flights we get that are detected, and then we can start processing that data. So let's look at our flights class. And here you can see it's pretty straightforward. All it has is it's got some general data, kind of like some header data that's included in that JSON string. And also it's got an array of what I call aircraft called AC. And here is the aircraft object. It's another public class aircraft. And all we're doing is we are setting properties for all of the different values inside of that string. And it will automatically, for each flight, it will get mapped to the description, the latitude, longitude, barometric altitude, track, company, and so on. And what we can do is we can take the raw data, we can process it, and put the results as properties in each of these aircraft. So basically there's an array of aircraft in our flights class, and we can just add as much data or as little data as we want based on what we want. Now, in order to get this information on what this data is, we can go back to the airplanes.live, and it explains all of the data that is sent. So we go back to the API, and under data field descriptions, we click on data field explanations, and it's got all of the fields that are included in the string that we receive. So for example, for each aircraft object, the following are shown if available. The aircraft, an array of JSON objects, one per known aircraft. And you can read this, it's got keys and so on. R is the aircraft registration, which we're going to be using because it has a unique identifier. We've got some messages that we're not going to be using, but we've got the flight, the call sign, the barometric altitude. And it's really important that you look to see what the format of the data is. So for example, barometric altitude, you'd think it'd be a double or a float. In fact, it is a string because it can return instead of a number. If it's on the ground, if the flight's on the ground, the altitude is 0, but it will return a string that says ground. All right, so it's really important that you set up your properties as the right format. In this case, the barometric altitude is going to be a string. You're going to have to parse it. Ground speed in knots, true airspeed, Mach. Track is the true track over ground in degrees, 0 to 359. Heading, and all of this stuff we can access to the extent we want. And then down here you can see there is a last position with latitude and longitude, which is what we're going to have to grab to get the location. So we're going to have the latitude and longitude and the track up here, true track over ground, 0 to 359 degrees. And here is an example output for one aircraft like we showed before. But basically we're going to set up our flights class to map whatever of this data we want, and then we can fill it in as we grab the data from the stream. So now that we have successfully grabbed a class object that contains all of the flight information for one time step, we face our first big design question. And the question is, these flights are basically physical aircraft. They represent physical aircraft with latitude and longitude and speed and heading and all physical properties. However, in our application, we're going to have to convert those to graphical properties that we can display in our picture box. So the question becomes, are we going to take all the graphics related properties of each real world flight and stuff them in this flights class? Or does it make more sense to separate them as a separate class or set of classes for the graphics associated with each flight, and somehow map them so that we have an aircraft class and then also an aircraft graphics class that have a index that matches so that we can say, okay, for this aircraft, we'll go to the aircraft graphics class to get its graphics properties so we can display it. So what we're going to do in the next video is we're going to look at one alternative. And what I've done here is I have created a flight graphics class that represents all of the graphics properties and methods associated with a single aircraft, which means its registration number, and that you can tie from the graphics class to the actual flight class. And this is kind of the common index. We also have picture box index and size. This is a graphics property associated with that flight. Picture box image. So we're going to have to rotate the image every time step as a particular flight changes. So these are the graphics properties associated with the aircraft with this flight registration. And then we have a image net rotation from 0. We're going to have a rotation value and also a pixel location represented by this point object. So all of these are graphics related that map to the individual aircraft. So we're going to have a constructor. We're also going to have some methods that do the conversions we're going to need. For example, we're going to convert from latitude and longitude to pixel values. You feed it a latitude and longitude, and it returns a pixel XY point. And then we can do a rotate image. We give you an input bitmap and an angle, and it returns a rotated bitmap. We're also going to have a method that does map ranges. We're going to do a lot of range mapping. For example, from latitude and longitude values to X and Y pixel values. So we're going to have to map the ranges. So we're going to talk about that in the next video. So that's it for this one. If you're liking these videos, I encourage you to hit the like button, subscribe, hit the bell notifications. But most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.